So let's kind of have a look at what this looks like and how it's going to integrate with what we do. So, there's kind of an image of what the sort of table we're used to. We have a schema with rows and columns. Every column obviously gets a name and a data type. And this whole idea really came out, NoSQL really came out of the problems of scaling. That application relational databases that had lots of users started constantly having to bring more servers online and running into capacity problems as they got more and more data. So that was the main motivation for this. But the other things that came out of it, one is we have to do a lot of work with a relational database in terms of translating the data in our database into objects in our application code that we can use. We want to display data from the database or save data to the database. The other issue is around flexibility, right? So we need to suddenly add a new field in our application. There's something new users want to store. We now have to go back into our database and change that schema on the fly. So the idea here was we could create a database where we didn't have to set up a schema ahead of time. We could just start dumping data into it. And that's one of the neat things we're going to see with MongoDB today. We can just start, we can create a blank database. We don't have to build any structure to it. We can just start dumping data in, and MongoDB will build a structure around whatever we put in. And then if we want to put something different in, no problem. We don't have to make any changes. We can just put in different things and still group them together. So they're designed to be fast. They're designed to be scalable. So some of the terminology we're going to use in this course is different from the database terminology we've used in the past. In relational database, we have records and tables. In MongoDB, we have documents and collections. So in a collection, not everything in there has to look the same. Unlike in a relational database, all the records in one table, they all have to follow the same format and have the same structure. So we have more flexibility here. One of the other things he mentioned in the video is there's no joins. So if we have related data in a relational database, we have, we may have your customer profile over here on Amazon, and then we may have your address book stored in the address table, and there's a connection. Right? All the addresses belong to you or tied to your customer ID. And if we want to pull up your address book, the code on Amazon.com needs to do a join between your customer profile and all the addresses in the address table. We don't need to do any of that with a NoSQL or a document database. We can actually nest inside your customer document. We can put all the address documents inside. This also works well with cloud hosting because cloud services are designed to auto scale. If more resources are needed, they just add another server automatically and charge you accordingly. So here's an example of what data in a MongoDB might look like. So this is one document or record. So for example, this would be a restaurant object. So all our data is just stored as key value pairs. So in MongoDB, basically our data is stored as a JSON object. To make it faster, rather than storing it as plain text JSON, MongoDB automatically converts that JSON into binary in a format called BISON. It stands for binary JSON. So it converts our JavaScript array into ones and zeros and stores it that way. So you can see within one document, we can have, so this one object has two different grades on 2 different days. So in a relational database, we would have, a restaurant table and then a grades table, and they'd be joined together. Every grade belonged to a restaurant ID. In this case, we can insert the child data right inside this single document. So this means when we want to query this stuff, we don't have to write any joins. We can just select this whole object and all the child data is here already. So it's going to be fast. The limit is if we have a lot of complex relationships, it gets hard to manage. So we typically don't want to do this if we have lots and lots of different tables and relationships. Need to jump around to turn the lights on, I think.
Where is the light sensor? There is somewhere. I guess we're all being really still. Yes, it is on.
One of the other things you'll notice, so there's no keys, but there is one field that MongoDB will automatically assign every time we insert a document. It creates automatically a field called _ID, and it gives it a data type of object ID and creates an encrypted or a generated unique identifier. So we never have to set up any kind of key fields. MongoDB will do this automatically. So the word Mongo actually comes from the word humongous. Right? It's got the word Mongo right in the middle, meaning really, really large. That was the idea, that it could be used to store lots and lots of data, okay, and it could grow rapidly. So it's not as mature as SQL Server, which is almost 30 years old, but it was created in 2007, so it is 10 years old now, and it's still the most popular NoSQL database out there. So we are working with something that's pretty well documented and quite well used. This is the most popular backend we see with Node.js applications. It's not our only choice, but it's the most popular choice. So we mentioned this already, that our data is just stored as JSON. That also works well because not only is our Node and Express code in JavaScript, it means our data is in JavaScript as well. So we don't have to we don't really have to convert data from the database into working with our web applications, are in the same format in JavaScript. So most cloud hosts will support it, and we can run simple queries. The query language is very kind of similar to the query language, the LINQ query language we used with ASP.NET. So if we wanted to run a query and find all the posts containing the title Mongo, we would just use this syntax, db.post, so that would be the name of our collection in the database, .find, and we could pass in some kind of criteria. We don't have to write a where clause, we don't have to write a join. So Alex, you mentioned queries were easy. That's what it would, that's an example of what a query will look like. It is somewhat similar. It is somewhat similar. Now, so the tools we're going to work with, we can either, and I would suggest you do both. Everything's free. So you do want to download and install MongoDB on your machines. And I asked everybody to set up a free account on mlab.com. All those links were on Blackboard. So hopefully you've had a chance to do that already. So there's no cost to us in being able to work with MongoDB. So we can either work locally or we can use MLab. I'll probably use MLab, but I'll show you how to do both. Obviously, for your next assignment in this class, you'll need to use MLab so your database is hosted online and isn't just a local database. So once we've downloaded it, it's actually self-contained, so you don't actually have to run any installer files. When you download MongoDB, you can just copy those files to any directory on your server, on your laptop, and run it from there. Okay. So let's try this out. Actually, I already have Mongo. So if you can go to the file where you've downloaded MongoDB, go to the folder. I guess I can download it again. So I could get the... So I just went to the community edition. So I'll save my file. Okay, so this is new. I hadn't updated mine. Before, MongoDB was only command line. There was no GUI to it. Nothing visual. So I'll just let that run. Now, the default path, MongoDB, it does require a directory. So anytime we start it up or create a new database, we actually have to create a folder telling it where to store our databases. By default, it looks for a folder called data, and then inside there a folder called DB. If we don't set that up, so it looks for it right in our root drive typically. Now, because I have from my command prompt, every time I open a command prompt, it opens it at C users and my username. So I typically create the data and DB directory in there. Just open up my command prompt for a second. So if you want to open up a command prompt, just look what's in here. So what we want to do is make a directory called data, and then in there make a directory called DB. So I already have one, I think. Maybe I do, maybe I don't. Oh, no, I don't. So that's fine. I'll make one in my command prompt. So I'll just make a directory called data. You can do this through your Mac Finder or through Windows. You don't have to do it through the command prompt.
Data or no?
You don't need Node. So it doesn't matter whether Node's there or not, but you do need to make a directory called data, and then inside of data, make another directory called DB. So make that directory, then I'll go into my data directory and make one called DB. Now I have this path, my username, data DB. So when I run the server locally, it asks what's the path to where the databases are stored. So I'll just put in that path whenever I run the server. Now this is new, this compass. They haven't had this previously. So I'm kind of curious to see what this looks like. So by default, MongoDB runs at this address, localhost :27017. So when we run MySQL, the default port for MySQL, I think, is 3306. The port for MongoDB is 27017. We can change that, but that's the default. There's probably no reason why we ever really need to change that. Okay, so we can actually do this right through this window. So I'm going to leave everything. Authentication is none. We're not using SSL. And I'll just click connect. Okay, and it tells me we're not running. So this is where we'll have to go to our command prompt and actually start up. Okay, so what we need to do is we need to use our command prompt to start the server. So what I've done here is I've gone into my program files MongoDB server, and inside of the bin, it has the program that we need. So normally we're going to launch this from the command prompt. So I'm just going to copy that path. So you want to browse into that folder. So if you're on a Mac, it'll be in your applications folder, MongoDB, inside of the bin. The application we need to run from the command prompt is this one, MongoD. That's the Mongo daemon. That's our local server. So right now our server's not running. The program is installed, but the server's offline. So before we can connect to it, we need to start our server. So I'm going to copy that path. And in my command line, I'm going to change directories and go in there. And now I'm inside of my MongoDB bin. So we want to run the program MongoD. And now we need to specify the database path. So now I'm pointing to the data folder that I just created up above. So start the server and store any databases in my new data directory. When I hit enter, this should launch MongoDB and the server should be running. So my server starts and it says that it's waiting for connections on port 27017. So our server's active now. We get a whole bunch of messages. So if I go back here now and click connect, now we're connected to our server. Now you don't have to use the local server at all. If you want, you can just use the MLab server. I'll show you that as well in a bit. So there are actually two databases already here. I'm going to create a new one. So I'll just click on create. I'll call it car tracker because that's what we're building. Now here they've said we have to also create a collection. We don't have to define any schema. So again, collection is similar to a table, except the collection is unstructured and the table is structured. So in here, let's create a collection called cars. We're going to dump some data in here in a bit. So now I have a database which I can click on. So we've got one collection with no data. So we actually have a little window here where we can insert a new document. So I'll click insert. So what we want to do now here is let's figure out, let's put some car data in here, figure out what fields do we want to store. So MongoDB automatically will assign an object ID. So what attributes of a car do we want to store? Remember, this isn't fixed forever. Our schema is flexible. But for now, what kinds of information should we store about a car? Okay. So we maybe call that make. Then I can just okay, what give me a car make we should store in the database. What kind of car do you like? What do you drive? Or what would you like to drive? Who drove to school this morning? Panka, what did you drive? Oops. Okay, I broke that. So make. Okay, maybe model. What model, Panka? Year? Okay, anything else we should add here? Okay, well, we can always come back and we can modify our schema later. So let's insert that. So just a simple JSON object. Let's insert a couple more. Who else drove today? Ryan, what did you drive? Model? And year? Okay. You can add any values you want. You don't have to copy the values that I'm inserting. And anybody else drive to school this morning? Okay, car that you want is fine. Yeah, what model, Rob? And year? Okay, so we've got 3 documents here. So now we can work with this data. We can start working this data in our car tracker application we've built. We want to be able to retrieve it, and then we want to be able to add to it and eventually update and delete. We may not get all that stuff done today. That's okay. Got a little bit of data here, and our server's running. So our query language is really simple. If we want to work from the command line, we just run the use command like we did. But now we have this graphical interface, kind of like MySQL Workbench as well, that allows us to see our data or insert it. So if we wanted to insert more data, again, just to see an example of schemaless, we could insert something like this. So we could insert one document that had 2 keys, but then we could insert into the same collection with 3. So let's try that. Let's insert one more. Anybody else drive to school today or get a ride in somebody else's car? So let's try this. Whoops. Delete that. But let's do one more car. But this time I'm going to add one more field. So we've added documents that have 4 fields previously. This time I'm going to put in a 5th one. Now, obviously, if I was working with a relational database, what would happen if I tried to do this? Right, I'd get an error saying there's no field called color, so my insert would fail. In a NoSQL database that has no schema, it doesn't care. I can add in new properties or attributes, and I don't have to make any changes first. So if we think about how this might help, for example, let's say we have some kind of product database, but we sell different types of products. Well, attributes that are related to some products maybe don't exist for other products. Maybe we sell physical products and they have things like a shipping weight. So we need to store a shipping weight or a size. But we have other products that are digital. Customers just download them. So we might have a download link, but we don't have properties like weight or size. In a relational database, we would need all these fields, which are going to be blank for many cases. In a NoSQL database, if one particular document has custom properties, no problem. It can be different from the schema of the other documents in the same collection. So this is quite flexible. Now we could try the same thing. Actually, you know what? It's 10:02. What we'll do now, we'll take a break. When we come back, we'll look at how do we get our Node application set up so that we can talk to the database. We'll try and pull this data into a page using Node and Express. We'll need to add some NPM packages. And then later on, we'll also move it so that rather than working with a local database, our database is hosted in the cloud on MLab, so that it doesn't just work locally, but it will work if we push our solution to the cloud. Okay, we'll take a 10-minute break here.